Okay, we're going to go through the derivatives of the other four functions. I want us to be able to cut here a second, make sure I got this right. I do, okay. Start again, take two, 3, 2, 1. Okay, so we're going to continue on with more trig derivatives. We've already done sine and cosine. We said that the derivative of sine is the cosine, and the derivative of cosine is the negative sine. So now we're going to do the other four, and they're really simple. I mean, they're in your book, but I thought I would explain step by step what happened here, so you can see what's going on here. The derivative of tangent of x. Well, we know the tangent of x is the sine over the cosine of x. And if you don't know that, you need to learn that, or put that in your toolbox as well. And that's fine. So we're going to take the derivative of this. So that means we've got the law of quotients here. So cosine of x is going to go on top here times the derivative of sine of x, which is the cosine of x, minus, because we're dividing here, the sine of x times the derivative of the cosine of x, which is the negative sine of x. And then the denominator becomes the square of the cosine of x, so cosine squared x. Then we resolve this. Cosine x is cosine squared x. Negative sine x times negative sine x is a positive sine squared x over cosine squared x. Now this is one of the most famous identities in trigonometry. If you don't know it, you should know it, but go ahead and put it in your trigonometric, your calculus toolbox. Sine squared, cosine squared, same as cosine squared and sine squared. It gives you 1. 1 over cosine squared gives you the secant squared. Therefore, your next derivative involving tangent will be secant squared x. For the next one, we're going to do cotangent of x, which is very similar to what we proved with the sine of x, because with the tangent of x, because tangent of x and cotangent of x are reciprocals or inverse of each other. So instead of sine over cosine, we start with cosine over sine, and then we go through the rule of quotients again. So that means sine of x times the derivative of cosine of x, which is the negative sine of x, minus, because we're dividing here. Now we put the cosine x here, and then we take the derivative of sine of x, which is cosine of x, and all that goes over the square of this denominator, sine squared x. Okay? Now we resolve stuff. We got sine x times negative sine x is negative sine squared x. Negative cosine x times cosine x is negative cosine squared x. And then we need sine x squared alone down here. Now, what's nice about this is that we can factor out a -1 out of this, and that leaves us sine squared plus cosine squared x, which is 1. So we got -1 there, and then we need the sine squared x. And as we know, cosecant is the inverse of sine. Therefore, cosecant squared is the inverse of sine squared. And we have a negative here in this, so we just write negative cosecant squared is the derivative of cotangent x. Okay? Otherwise, it makes, if you look at the first one, the tangent of x, so it's pretty similar to this, except it does have an extra negative sign. So be careful when you write it down in your calculus toolbox. Okay? Okay. Next one, we're going to do the secant of x. And as we know, the secant of x is the inverse of the cosine of x. So we're going to use the law of quotients or rule of quotients for that. That makes it really easy because you take the cosine of x here and multiply by the derivative of 1. Well, 1 is a constant, so that's 0. So that just drops the whole term out. Then we take 1 here times the derivative of cosine of x, which is the negative sine of x. Now this is a minus sign before, and this is a minus sign, negative sign because of the cosine, and then you multiply both by -1. Well, they multiply by each other to give you a positive value. So it gives you sine of x over cosine squared x. Now, there's a little trickery here to show this next part here. But since cosine squared x is cosine of x times cosine x, and since sine of x is sine of x times 1, you can separate that into two different fractions that are multiplied together to give you this value right here. And as we know, sine of x over cosine of x is tangent of x, and 1 over cosine x is secant of x, So the derivative of secant of x is tangent x times secant x, or if we turn around, secant of x times tangent x. It makes no difference how you write it, as long as you have them both in there. So put that number 5 trigonometric derivative into your toolbox as well. Okay? Now, for the cosecant of x, it's exactly the same idea as the secant of x. You start with the inverse of cosecant, which is 1 over sine. And we do the same thing. You take sine of x times the derivative of 1, which is 0, that drops that thing out, times 1 times the derivative of sine of x, which is cosine of x, over the square of that denominator. Well, this is negative cosine x over sine squared x. And we do the same little trickery that we did with the previous one, and that is by separating this into sine x times sine x, and have negative cosine x times 1, and it gives you two fractions multiplied together to give you that value there. Negative cosine x over sine of x is negative cotangent of x, and 1 over sine of x is cosecant of x. So your derivative of your cosecant of x is equal to negative cotangent x cosecant x, or you can flip them around. Again, multiplication is commutative. Makes no difference the order in which you multiply. Negative cosecant x times tangent of x. So put that into your toolbox. You now have all 6 derivatives of your basic functions, and then you can use that in your derivations for your problems that you are going to have. All right? So go on to the next part and look at some practice problems, and then have that.